Hey everybody, my name is James Carl and I apologize for my voice. I've been sick the last couple of days. This is my first physics lab video, and it's about Newton's second law. Newton's second law is a way to describe the motion of an object over a plane. The way I'm doing this is I went out in the world, took a video, brought it back to my room, did some various things to it, discovered that you could use a program to track its exposition and see how the motion can be compared to a predicted model. Newton's second law, as you know, or may not know, is that velocity final equals velocity initial plus F net times delta t over mass. In layman's terms, it's just a formula that you plug numbers into. But in this situation, in this lab, the F net for my experiment was 0 because we are anticipating constant velocity. Also, another thing we were looking at is predicted motion, which is RF or R final equals R initial plus delta V times delta T. It's just a way to test and see the difference in change or position of an object. Things you should know before I start. The mass of the ball was 0.17 kilograms. It's the average, well, I weighed it. The beginning position was at the origin of the axis, which was 0, 0. My predicted velocity was negative 0.474. I got this using the points I will show you later on, which were negative 0.063 minus 0 because it was the starting time, divided by 0.133 minus 0, which is the amount of time elapsed. Here's tracker, and this is my video. I went out into the world and video recorded a billiards ball in order to display the change, display Newton's second law. Here's the video. As you can see, every frame it jumps, I leave a point of mass where the thing is along my axes. These axes is the normal axes that you would use in any sort of calculus. What would happen if I flipped these axes so that this side was the positive side, this side was the negative side? This line would be positive as all of my data would be positive. It would change no data. It would just mean that my velocity was positive 0.474 instead of negative 0.474. Using this program, it gave me this data. And I threw this data together into an Excel spreadsheet. This is the Excel spreadsheet that I put it into. This first sheet was only a exposition model. As you can see, I used the time and the values of the expositions at that time. And you can see that it's pretty straight. I would say that that's a fairly straight line. There's a little bit of a curve, and I will tell you why there's a curve in a second. This is the predicted exposition. What I did was I used that velocity of negative 0.474, and I created a line. It was very simple. This was what Newton's second law predicted my ball should roll at. And I put the two graphs together to show a little bit of comparison between the two. As you can see, the lines split apart. There's a large, well, not large in the scheme of things because it's a very small number, but there's a big difference between the 2 points here. And the reason for this is friction. Newton's second law does not account for friction because it is expected to be there should be no friction, and the gravity asserted on the object should be negligible. I took this information and threw it into Python, and I used the code. The code doesn't mean much to you guys, but what does mean anything is the model that is generated from the code. This model is slowly moving to the left, as you can see, because it's very small, but here's what you really want to look at. This is the computer-generated model of the distance that my ball traveled because it's in the negative direction to the left of the axis. That's why it's moving down instead of up. It's one of the difficult things about this lab was that because the ball did move a little bit to the left and to the right, and the angle of the camera may not have been perfect, it's hard to tell. It's hard to tell if all of the motion described by this and by the other page was because of either friction or camera distance and the ball wobbling. It's hard to say, but in conclusion, this lab was about Newton's second law. We discovered that it doesn't always meet the prediction in the real world, and because of that friction, Newton's second law can be seen anywhere. And I'd like to thank you for watching this video. Thanks.